Before our eyes unfolds something that until recently seemed like science fiction. A robot dog with intelligence is learning to play badminton with a human, and doing it not just confidently, but with truly spectacular performance. A video published on the YouTube channel of ETH Zurich demonstrates what modern robotics is capable of when computational power, adaptive algorithms, and outstanding engineering come together. This is ENMLD, the latest version of the legendary Swiss robotic platform. But this time, it does not just walk, climb, and balance like its predecessors. ENMLD is now equipped with an arm, a precise and fast manipulator with which it holds a racket and plays badminton. At the core of ENMLD is advanced mechatronics. It moves on 4 highly maneuverable legs that provide perfect stability and dynamic adaptation to any surface. In its arm are next-generation servomotors that enable sharp and accurate hits. But the real magic lies in its brain. Control is handled through a reinforcement learning system. The robot is not simply programmed to strike. It learned to play through simulation. ETH Zurich has once again proven that Europe is not falling behind the American or Asian directions in robotics, and in some areas it may even be ahead, particularly in engineering precision, algorithmic flexibility, and architectural elegance. Recently, the Chinese military equipped quadruped robots developed by Deep Robotics with various firearms. These robots have been fitted with automatic rifles and other tactical gear mounted on their backs, effectively transforming them into fully functional mobile combat platforms capable of engaging targets. These mechanized robot dogs demonstrate high stability and can move across rough terrain, jump, lie down, stand up, and even retreat backwards. Remotely controlled, they are capable of operating both individually and in coordinated groups, carrying out missions such as reconnaissance, fire support, and building clearance. Essentially, these are robotic fighters that could soon be actively deployed in the Chinese Army's arsenal for urban combat scenarios and frontline operations. Deep Robotics has been advancing its technologies in civilian and industrial sectors for several years, but now these innovations are finding applications in the military domain as well. Chinese company Anywit Robotics has unveiled one of the most emotionally realistic humanoid robots in the modern industry. What makes this development remarkable is not just its technical specifications, although those are certainly impressive, but how subtly and almost humanly it interacts with the world around it. This is not just a machine. It is a system created not merely to perform tasks, but to perceive, understand, and respond. Its behavior, facial expressions, and gaze are not programmed in a linear fashion, but trained on real human reactions through advanced neural network models and adaptive learning algorithms. The robot can recognize human facial expressions, vocal intonations, micro-movements, and even respond to emotional context. Physically, the model is built around an ultra-precise actuator system that allows it to reproduce the tiniest facial and neck movements. This is not just about turning its head or smiling. This is genuine facial expression, with synchronized movements of eyebrows, cheeks, eye muscles, and lips. Visually, the robot creates a sense of presence, as if you are facing a real conversation partner rather than a device. What leaves a particularly strong impression is its gaze. The camera sensors in its eyes are synchronized with a dynamic pupil tracking system, creating a sensation of mutual awareness, as if it is truly looking at you, not just detecting an object. The American company Tombot has developed a robotic dog named Jenny, a lifelike companion designed to provide emotional support for people with dementia, Alzheimer's disease, autism, and other cognitive impairments. Jenny looks and behaves like a real Labrador puppy. She can wag her tail, turn her head, move her ears, and respond to touch, voice, and surrounding sounds. Thanks to built-in sensors and motor functions, the robot displays realistic behavioral responses, including twitching, snorting, and even showing joy when interacting with her owner. Jenny cannot walk. This is intentional, to reduce risks for elderly individuals by eliminating the possibility of tripping over the device. Instead, she is designed to be held in one's arms or placed on a lap, providing both tactile and emotional stimulation. The robotic dog runs on a rechargeable battery that lasts for an entire day of use and is controlled through a mobile application where responses and modes can be customized. The Chinese Army has also unveiled combat robot dogs from Unitry, equipped with automatic firearms. These quadruped platforms are capable not only of navigating difficult terrain, but also of firing accurately while on the move. Thanks to built-in stabilization systems and remote control, the robots can shoot steadily even during motion. They can be used for reconnaissance, building clearance, perimeter security, and combat operations in environments too dangerous for human soldiers. The model, presumably the Unitry B1, is known for its high maneuverability and payload capacity, making it easy to mount rifles, cameras, and other tactical equipment. The emergence of such armed robots signals a rapid evolution in military technology, where autonomous machines are becoming fully operational fighters on the battlefield. South Korean engineers have unveiled an advanced robotic dog called Rybo, developed at the Raylab Robotics Laboratory of the Korea Advanced Institute of Science and Technology. Rybo is a next-generation quadrupedal robot designed for confident movement in complex, unstable, and unstructured environments. Unlike many other robots, Rybo can adapt to various surfaces thanks to its active balancing system and advanced motion control. It is equipped with an artificial intelligence system capable of processing sensory data in real time, enabling it to navigate without external assistance even in rapidly changing conditions. Rybo's design features lightweight, high maneuverability, and autonomous operation capabilities, making it well-suited for tasks such as inspection, search and rescue missions, and operations in hazardous areas inaccessible to humans. At a recent demonstration, the Japanese company Kawasaki unveiled one of its most practical robots named Robotic Nimbus, developed in collaboration with Tohoku University. This innovative robot is designed to support individuals with limited mobility, providing them with stability and safety while moving. It can adapt to various surfaces and environmental conditions, ensuring stability and preventing falls. The robot uses sensors and artificial intelligence algorithms to analyze both the user's movements and the surrounding environment. One of the key features of Robotic Nimbus is its ability to move autonomously and follow the user without the need for manual control. The Chinese company Limex Dynamics continues to captivate the public with its latest development, Tron 1, an innovative bipedal robot capable of adapting to various environments thanks to its unique modular design. Tron 1 combines 3 modes of locomotion: a classic walking gait, wheeled movement, and point contact support, making it a versatile solution for both research and practical applications. Standing at approximately 85 centimeters tall and weighing less than 20 kilograms, Tron 1 is equipped with a 12th generation Intel Core i3 processor, 16 gigabytes of random access memory, and 512 gigabytes of internal storage. Tron 1 demonstrates outstanding stability and the ability to overcome obstacles, including stairs and uneven terrain, thanks to its advanced motion control algorithms. Additional modules, including a robotic arm, voice control, and sensory extensions, expand Tron 1's functionality, making it an ideal tool for research in artificial intelligence, robotics, and human-machine interaction. Write in the comments what you liked most after watching this video. If you enjoyed this video, don't forget to subscribe to our channel and leave a like. See you next time.